All right, so we're doing section 3.4, which we're going to look at graphs and models and different way the graph's going to look. So let's go ahead and just dive in. So we're going to look at the graph of f of x equals ax to some power. Okay, so whether that power be a 1, a 2, a 5, whatever. If it is an odd number, such as a 1, a 3, a 5, as we have examples right here. So each graph above has odd degree and is an odd function, exhibiting symmetry about the origin. Each domain is all real numbers, and the range is also all real numbers. And it is continuous on the entire domain of all real numbers. Additionally, these odd functions are increasing on their entire domain of all real numbers, appearing as though they fall to the left and rise to the right. So basically, as you're coming in from the negative side, the y value is also getting bigger. So they're increasing on the entire domain. As you keep going, even on this one here, if you pick this number and you go to the next x value, you've moved up the y-axis. So when you have an odd function, this is how it is going to look. It's going to be increasing across the entire domain. Now, here we have our even numbered graphs, so our even degrees, and these are going to be even functions, and they're going to exhibit symmetry about the y-axis. Each domain of all real numbers, but each domain is all real numbers, but the range is restricted. The range will be the minimum value will be the lowest, because like this is the lowest value. You're not using any of these. So it'll be whatever that minimum number is to positive infinity. These even functions are also continuous on their entire domain of all real numbers. However, they are decreasing from negative infinity to 0. So here, if I were to choose any x value, as I choose another x value, as my x values increase, my y value is going down. But once you get to that minimum point, you're going to start increasing from that minimum value back up. And these are going to appear to rise both to the left and to the right. All right, so now that is just kind of the way they look in a nutshell. But we're going to look at just your general things, your general rules. So the absolute value of a in a function, a x sum n, determines the width of the graph. So this number that is in the very front of your function, this is going to determine if it's wide or narrow, okay? So if the absolute value of a is greater than 1, then this is stretched vertically, making it narrow. Here, let me write that a little better. That looks terrible. Making it narrower. And when that a value, the absolute value, because whether it's negative or positive tells you if it opens up or down, but just the number itself, if it's greater than 1, it's going to be a skinnier graph, because that means your y values are getting bigger. And if it's between 0 and 1, then it's going to be shrunk or compressed. Okay, when a is between 0 and 1, the graph is shrunk or compressed. So your y values are getting smaller. making it appear to be wider. We think that if it's shrinking that it would be getting smaller, but it's getting wider because the y values are getting smaller, so it kind of has a opposite effect. All right, so now if we take that same ax to the n, now if we put a negative sign in front of it, it's going to reflect across the x-axis. So if you have your x and your y, if we have a graph here, it's going to reflect over and it's going to be down there. And then if you take and you add some number to the entire function, it's going to shift up that many units. And if k is negative or less than 0, it is going to shift down that many units. And then if you take the same graph, or the same function, sorry, now if you subtract something from the x value or add something to the x value, it's going to cause it to shift to the right or to the left, depending on the value. So notice that it is an x minus h. So if it says x minus 2, you're going to go to the right. If it says x plus 2, you're going to go to the left, because that means if you have a positive, that means you subtracted a negative, making it move to the left. And then if you have a function that looks like this, this is a combination of all of the things we just discussed. All right, so let's get in and just dive in there and start doing some examples. I'm going to show you a way that may be a little different than you may have seen it in the past. And if you already have a method for doing this because you learned it in Algebra 2, keep doing your method. If you haven't, then maybe this method will help you grasp the concept. So it says, graph each polynomial function and determine the largest open interval. Okay, so what we're going to do is I want you to think about x to the fifth. Okay, so if you just think of x to the fifth as being your graph. So no matter if we have x and then we have x to the fifth. So let's just choose some values. I'm going to choose -3, -1, 0, 1, and 3. So if you plug those into x to the fifth, then you will get your parent function. Hang on, let me grab my calculator. Okay, so I am going to type in x to the fifth, and hopefully you have gotten a TI-84 because it makes life so much easier. So if I were to plug in -3, then my answer would be -243. If I plug in a -1 to x to the fifth, my answer is just -1. 0 would be 0. Plug in a 1, it's still -1. Plug in a +3, and we get, let's see, +1 is going to give us, back up. If we plug in a +1, we get 1, because +1, no matter how many times you multiply it as positive, plug in a +3, and now we get +243. Sorry about that. Now when you graph this, what's going to happen, trying to get my, so obviously -3 and -243 is like way down here. Then we have -1, -1, 0, 0, 1, 1, and +3. 243 is way up here. So what is going to happen is you're going to have a graph that looks like that. All right, it's kind of more flat, but general idea, okay? Now, this says to take your parent function, that x to the fifth, and subtract 2 from all of the y values. So what you're going to have is you're going to have your x values are going to stay the same, but y, you're going to take these y values here and just subtract 2 from all of them. So if you use the same exact x values, because it says to not do anything to the x value,
Then just subtract 2. Now we got negative 245, negative 3. 0 minus 2 is negative 2. 1 minus 2, or sorry, 1 minus 2 is negative 1, and 3 minus 2 is positive 1. So now when we graph this function, you've got negative 3 and negative 245. Now it's down here a little further. Negative 1, negative 3, 0, negative 2, 1, negative 1, and 3, 1. So now you've got, oops, you got the graph and it looks like this. And then it says to determine the largest open interval of the domain over which the function is increasing or decreasing. As you are coming in from the negative, no matter what, your y values are going up. So this is increasing. Across your all real numbers. So across your whole domain, it's constantly increasing. As x gets bigger, y gets bigger. All right, so let's slide over here and do this one. Now, notice that this time the x, instead of adding your 1 to the end of the function, you're adding it to the x value. And this, our parent function this time, we'll call this g of x, is x to the 6th. So what we're going to do is I'm just going to do the same thing. I'm going to do my x and y's for the parent function. And I'm just going to grab some positives and negatives. You'll probably see a pattern. I just always grab those smallest ones there. So now if you go to your table, if you go to your calculator and you just plug in x raised to the 6th and go to your table, you can see that when it's negative 2, it is 64. Negative 1 is 1, 0 is 0, 1 to the 6th is 1, and 2 to the 6th is 64. So now when we graph this, we have negative 2 and 64 is way up here. Negative 1, 1, 0, 0. The distance between your x or between your y values moves very quickly when your exponents get bigger. 1, 1, and 2, 64. So you've got this graph here. So now it says, okay, now I want you to subtract 1 from all your x values. So now you're going to go x minus 1, and then your y values, it doesn't say to change your y values. So we're just going to leave the y values alone, okay? So now, going over here, take your negative 2 and subtract 1. So let me go back to my calculator. I'm going to type it in so I can get my x minus 1. I always like to make sure that I don't make any typos. Okay, so now, if we go to, all right, so negative 2, so it says to take your negative 2 and subtract 1. So negative 2 minus 1 is negative 3. Negative 1 minus 1 is negative 2. 0 minus 1, 1 minus 1, and 2 minus 1. Now what happens to the y values? Well, the y values are going to change. We didn't have a negative 3 up here, but now this is going to be 4,096. Now your negative 2 is 729. Your negative 1 is 64. 0 is 1, and 1 is 0. So now this is what the new graph looks like. So now when we graph it, what you have done is you've taken this graph here, and it says to minus 1, so that means you're going to shift to the right 1 unit. So now we're going to go negative 3, 4,096 is way up here. Negative 2, still way up here. Negative 164, still way up here. 0, 1, now we're here. And 1, 0, now we're here. And what I do need, I'm going to slide this up. I need a couple more numbers so that I can, because I know I'm going to come in like this. Your graph's going to look the same. So we know we're going to come in. Let's see here. Let's do a positive 2. So a positive 2 is, we got x minus 1. Make sure I've got everything typed in correctly. Oh, it's x plus 1. So because I covered up my own work. So we are shifting. And we're going to shift left. Be careful when you cover up. So let me go back and let me fix this. So since it says plus 1, we know we're subtracting 1 from our x values, okay? So you're going to, because you take that rule, so we have x minus h, okay? Since it says plus, that means we said x minus negative 1. So that means we're going to subtract 1 from our x values. So negative 2 minus 1 is 3. Negative 1 minus 2 is negative 2. 0 minus 1 is negative 1. 1 minus 1 is 0. 2 minus 1 is 1. And I'm going to grab a couple more numbers so that I can make sure I get the full effect. So this would be 2 minus 1 would be 1. 3 minus 1 would be 2. And 4 minus 1 would be 3. So we'll just go in order. Now, if you go to your calculator and go to your table, the negative 3 is 64. Negative 2 is 1. 1 is 0. 0 is 1. 1 to the 6th. 1 plus 1 to the 6th is now 64. Let me change my color here so we can see through. I hate the little bottom piece here. So now we've got 2 plus, so this is 729, and then 3 would be 4096. So that's backwards. All right, so now let's come back over here. We got negative 3, 64 we said is way up here. Negative 2, 1, negative 2, 1, negative 1, 0, 164. So we're back up here. 2, 729. We're way up here. And so now what we've done is we've taken our graph, same graph, and we have shifted it to the left 1 unit. So now as we're coming in from the negative infinity side, as we're coming in from negative infinity, our y values are also decreasing. And then when we get to that minimum point, then as our x's get bigger, we start increasing back on the y. So what we're going to see here is we're going to see that we are decreasing from negative infinity, and you're going to want to look at your x values. So the minimum value now on the x-axis is a negative 1. And then from that negative 1, we start coming back up and start increasing. So coming in from negative infinity, coming in, we're getting smaller, smaller, then we hit that point, and then as we keep going on our x value, our y values start going back up. So look at the x values along your domain, because that's what they want to know, is if you're increasing or decreasing along your domain. What problem it was now? This one here, our k was, oh, this was looking at our domain. Our k on this one, we didn't have a k. I'm talking about this one here. So the 2 is your k. So that's where, all right, this one has them all tied together. So what I want to do here is we have negative 2 times x minus 1 cubed plus 3. So our parent function is x cubed. So we're going to grab some values. So -2, -1, 0, 1, and 2. And we're just going to cube them. So -2 cubed is -8. -1 cubed is -1. 0 cubed is 0. 1 cubed is 1. And 2 cubed is 8. Now, all of these things happening in this picture, there's a lot. We see a reflection. We see a stretch. We see a shift. And then we see another shift. So the order does matter. So the first thing you're going to take care of is kind of like starting from the inside and working your way out. So the very first thing we're going to do is we're going to look at this piece here, and it says x minus 1, so that means we're shifting right 1. So this is a horizontal shift. Right 1 unit. So you're going to take your x values and you're going to add 1 because we're shifting right, and our y values will stay the same because this one piece right here only says to shift right 1. The next thing you're going to do is you're going to do your vertical stretch. Okay, so our next thing is going to be a vertical stretch by 2. And that's coming from this 2 right here. So a vertical stretch. So now the x value for just that piece, the x value doesn't change, but you're going to multiply your y values by 2. Then the next thing we're going to do is we're going to reflect this little negative right here. It says reflect over the x-axis. Your x values stay the same and your y values will change. And I'm just looking at each one of these rules as one, and then when I have all of my rules together, then I will combine all the rules and come up with just one. And then the last thing we're going to do is we're going to look at this 3 right here, and that's going to be your shift up, just like that first example we did. So this is a vertical shift up. And knowing whether you're doing vertical or horizontal depends on, it's important to know the difference because that tells you what you're doing to your x or your y value. So since we're shifting up, x will stay the same for this rule, but your y value will increase by 3. So now I have these 4 rules. If I combine them all together, I can come up with one rule, and then I'm just going to I'm going to use that one rule on this table, and then I will get my new table. So now I'll have, well, actually, don't put x and y here yet because that's going to be our rule. So now look at all your x's. We have x plus 1, x, and x. So that means x plus 1 is my rule. I have y, 2y, negative y, and y plus 3. So we have a negative 2y plus 3. So now take this same table and add 1 to your x's. Negative 2 plus 1, negative 1 plus 1, 0 plus 1, 1 plus 1, and 2 plus 1. And now take these x values here and plug them in. So negative 2 times negative 8 is 16, and 16 plus 3 is 19. Negative 1 times negative 2 is 2. 2 plus 3 is 5. Negative 2 times 0 is 0. 0 plus 3 is 3. Negative 2 times 1 is negative 2. Negative 2 plus 3 is 1. And negative 2 times 8 is negative 16. And negative 16 plus 3 is negative 13. So these are going to be the points for this function. So negative 1 and 19 is going to be up here somewhere. 0, 5, 1, 3, 2, 1, and 3, negative 13. So this one is going to look like this. So how is it increasing? How is it decreasing? So as we're coming in from negative infinity, so as we're coming in, we're going to decrease along our domain. So from negative infinity to positive infinity, we are decreasing along all real numbers. And we know that because that negative right there. All right, hopefully this made a little bit of sense. We'll get a little more practice on a few more problems. Okay, it says, unless otherwise restricted, the domain of a polynomial function is the set of all real numbers. Polynomial functions are smooth, continuous curve on the interval of all real numbers. And the range of the polynomial of odd degree is the set of all real numbers. Now, the polynomial function of even degree has a range from negative infinity to k, or from k to positive infinity. And if you remember that one where we had the x squared plus 2, or the, I can't remember, domain will come into play when you have an even degree. Let's see if I have an example of one of even degree. Like if we had x to the fourth plus 4, then as your x was increasing, y would decrease, but it's only going to happen until we get to this number here, which would be 4. So it'd be from negative infinity to 4, and then from 4 to infinity would be when it would start, because this would be your vertex point. That would be the lowest point on your graph. So you would decrease until you hit that low point, and then once you hit that low point, you would start to increase. We're going to talk about our behaviors at 0. So the graph crosses the x-axis at c, some number c. So when you have a line, it's crossing here, or maybe it's a negative slope, crosses here. And this is when you have a multiplicity of 1, meaning this could be like x plus 1. There's no exponent. The exponent assumed to be 1. The graph is tangent to the x-axis, some number c0, if c is a 0 of even multiplicity, like if you had x plus 1 squared, that would be multiplicity 2. And it crosses and is tangent to the x-axis at c0, some number c, if you have odd multiplicity greater than 1. So let's say we have that x plus 1 cubed. So now we have a multiplicity of 3. Here we have a multiplicity of 2. Here we have a multiplicity of 1. All right, so when you see something squared, you know it's just going to bounce. And when you see something cubed, you know it's going to go through. And if it has a multiplicity of 1, it's also going to cross. So always remember that. I have a little table I want to share with you once we get through all the rules. And it kind of helps make you remember. Because if you can remember basically 2 of the rules, then the others are whatever those 2 aren't. So think about this graph right here. We had a odd multiplicity. Notice that our graph looked like this. So the right side pointed to the left, and the left side pointed down, and the right side pointed up. So that was as our x values got bigger, our y values got smaller. So let's talk about turning points. Turning point, basically like the one where we said we're decreasing until we get to a point, then we start increasing. That would be considered your turning point because things are changing. All right. A polynomial function of degree n has at most n minus 1 turning points. So if I am squared, then I'm only going to change direction 1 time because 2 minus 1 is 1. So there's only 1 turning point. So suppose we have a times x to the n is a dominating term of a polynomial function of odd degree. So we're looking at odd numbers right now. So as our a value, if our a value is greater than 0, then as x is approaching infinity, so as you're coming in from the negative, then your function will also be reaching infinity. And as x approaches negative infinity, then your graph will approach negative infinity. We symbolize the end behavior as, that's what your ends are going to look like. This will make more sense in a second, I promise. It's kind of crazy right now. If your a is less than 0, then as x approaches infinity, f of x approaches negative infinity, and as x approaches negative infinity, f of x approaches positive infinity. And we symbolize this behavior as that end points that direction and the right side points that direction. So think about, was it on this page? So as because we're talking odd degree multiplicity, so as our x values got bigger, our y values got smaller. Oh, because we were less. As our x values got bigger, our y values got smaller, and this is the graph. It looked like this. Now, if you're looking at an even degree multiplicity, like x squared, x to the fourth, things like that, if your a is greater than 0, then as x approaches infinity, f of x approaches positive infinity, and we symbolize the end behavior as both sides going up. And if your a is less than 0, as x approaches infinity, f of x approaches negative infinity, and this one looks like this. Because if you're squared, you're going up. If you're negative x squared, you're pointing down on both sides. So we're going to just use that information, and we're going to match these graphs to their equations based on what we know. So we have an even multiplicity. Our a, which is here, is greater than 0. So we're going to go up here. We have even degree. Our a is greater than 0. So both sides of my graph have to be pointing up. So this is going to be C. So this is my f of x graph because it's even. This one is cubed, so this is our odd degree. So we're going to look at these rules up here. Our a is greater than 0. So that means the right side points up and the left side is down. So the right side points up and the left side points down. So this is our h of x. We have an even multiplicity, so we can use this rule here. We have a negative 1, so our a is less than 1, or I'm sorry, is less than 0, and so both are going to point down. So this is going to be our g of x, because they're both pointing down. And then obviously this one is going to be k of x, but let's talk about y. We have odd multiplicity, and our a is less than 1. So odd degree, our a is less than 1. So now the right side points down, the right side, so the other side points up. So this is our k of x. So this is kind of how my little chart, how I make a table. All right, so we either have odd or even, and we either have a is greater than 0 or a is less than 0. So those are your two things, right? So think about when it is odd and less than 0, the right points up, so the left points down. If your a is less than 0, now the right will point down and the left will point up. When it's even, if the right points up, the left points up. When it's even but less than 1, if the right points down, the left points down. So you need to remember the right-hand side. So if it is if it's an odd exponent and a is greater than 0, the right points up. If it's even and greater than 0, the right points up. If it's odd and less than 0, the right points down. If it's even and less than 0, the right points down. So if you can remember what the right side is doing, then if it's even, they're the same. If it's odd, they're opposites. And then we will do some examples using this and using those rules as well. We made, so we have an odd degree and A is greater than 0, so the end, the right is going to be up and the left is going to be. Okay, let's look at how does the term of greatest degree of polynomial function determine the end behavior of the graph of the polynomial function. So if the term A is greater than 0, the right side goes up. So if A is greater than 0, the right side goes up. And if A is less than 0, the right side goes down. All right, so here is that polynomial function, the really long one, the a sub n x to the n all the way to a sub 0, as long as a to the n is not 0, will be a polynomial function of degree n. To sketch this graph, follow these steps. So first you're going to find real zeros so we can plot them. Step 2, you're going to replace all of your x's with 0. And step 3, use the end behavior to determine if it crosses or touches. And determine if it crosses or touches. All right, so let's look at this first one. So the first thing we want to do is find your possible zeros, since they didn't tell us any of them. So remember that the first is Q and this end term is P. So we're going to find the factors of P. So if P is 6, then my factors are positive, negative 1, positive and negative 2, positive, negative 3, and positive, negative 6. And then Q is a 2, and our factors are positive, negative 1, and positive, negative 2. So your possible zeros so we've got 1 over 1, so positive, negative 1, 1 over 2, so positive, negative 2. And we got 2 over 1, which we already used, and 2 over 2, which is 1. We've already used that as well. All right, now we got 3 over 1. Oh, we have the positive, negative 1/2 also. 1 over 1, 1 over 2, 2 over 1, 2 over 2. 3 over 1, which is 3. 3 over 2, which would be 3/2. We got 6 over 1, which is 6. We have 6 over 2, which is 3. 6 over 3 is 2, and 6 over 6 is 1. So we only have to worry about those 6 terms. So choose one. I'm not going to choose one of the negatives, but I'm just going to start with a 1. I'm going to see if this will go into, we got 3, 2, 1, 0. So 2, 5, negative 1, negative 6. So let's see if we can determine one of the zeros. 1 times 2 is 2. 5 plus 2 is 7. 1 times 7 is 7.
Negative 1 plus 7 is 6. 1 times 6 is 6, and negative 6 plus 6 is 0. So since I have a remainder of 0, then x minus 1 is a factor. So 1 is a 0, so x minus 1 is a factor. So if this started out as my x cubed, then this is 2x squared plus 7x plus 6. So now I'm going to factor this out. So my leading coefficient is a 2. My 7 is in the middle. 2 times 6 is 12. My factors of 12, 1 times 12, 2 times 6, 3 times 4. Well, I know 3 times 4 will give me 12, and 3 plus 4 will give me 7. This side will reduce to 2 over 1. So this is 2x plus 3, and this is x plus 2. And then we have our x minus 1. So those are our factors. But they want me to find the zeros. So now I know that this is a 0. Change the sign. That's a 0. Change that sign. That's a 0. So there are your zeros of the function. All right, step 2, I used part of my space here. All right, so step 2 says to replace all of the x's with 0, because it says f of 0. So if I go to my original function up here, it's 2x to the third power plus 5x squared minus x minus 6. And if I replace all of the x's with 0, that's going to cancel out, that's going to cancel out, that cancels out. So when x is 0, y is negative 6. All right, so now, well, that little table, just found out over here that we are going to cross the x-axis at 1, negative 3/2, and negative 2. Negative 3/2 and negative. We just found out also that when x is 0, y is negative 6. Look at what we have here. So step 3. Step 3 is to use your end behavior, find out if it touches, crosses, and get a general idea of what this is going to look like. And we're going to use those graphing calculators, so hopefully you have gotten those. All right, so our equation is 2x, actually, let me write it the way they have it. So 2x cubed plus 5x squared minus x minus 6. So what I know is that, first of all, my degree is odd. So I have an odd degree. So that means something. So we have odd degree, and a is greater than 0. So remember, if you go back to, so we know that the right is going to be up and the left is going to be down. So whatever's happening in between here will be determined by our points that we're going to use. So what we know for a fact, so x's are negative 1, negative 3, or was it positive? Oh, shoot, 2. So positive 1, negative 3/2, and negative 2. All right, so we're going to have a point here. We're going to have a point at negative 3/2 is negative 1.5, and negative 2. So those two are really close together. And then we know that from this point up, because we said that the end behavior, so this is our last point from the graph going up, and then from this point going down is going to be that way. So now we just need to figure out what's going on in here. So when x is 0, y is negative 6, so we're going to cross to that point. So coming from here down to here, And then what we're going to do next is we know that because these are our x-intercepts, so we know our factors are going to be x minus 1 to the first power, x plus 3/2 to the first power, and x plus 2. And they're all multiplicities of 1. So that means through each one of our x-intercepts, we're going to go through it. That's why I knew when I come down through here, I knew I was going to cross it because it had that multiplicity of 1. So now the next thing we're going to do is I'm just going to set up like a little, like we did in the other activity on another section where we set up our intervals and we did test values to see if we were above or below. That will also help us create our curves to know what's happening here. So we know that we're going to cross through this point and we're going to cross through this point. So let's create our table here. So we have -2, we have -1.5, and we have +1. So create your intervals. So on this side of the interval here, let's use -3. Between -2 and -1.5, there's really not a lot of options. We're going to use -1.75. From -1.5 to +1, we do cross over 0, and then I'm just going to use 2 over here. Now remember, if you have that graphing calculator, or even if you use Desmos, you can type this in to the calculator into y equals, and then go to the table, and then look at these points, and look at the answers, okay? So if we go to y equals, and we type in 2x raised to the third power plus 5x squared minus x minus 6. 2x, this did not work out, 2x3 plus 5x squared minus x minus 6, and then I'm going to go look at my table. So I want to look at -3. So -3, when I plug a -3 into this, it gives me -12. So this tells me I'm below. So from here to here, I am below, which I knew because that's my end. Now look at 1.75. So 1.75 is between, let's see, between -2 and -1.5. Let's see, I know from, okay, I'm going to have to see if I can. I'm going to count my table by 0.5s. Okay, so now I know that between 2 and 1.5, between -2 and 1.5, so those are both zeros. So I'm going to have to change my, let's count by 0.25s. All right, so I'm looking for -175. So that is it gives me a positive answer, so I know I'm up here. So now when I come out of this point, I know I'm going up. And then now I'm going to test the point 0. And the point 0 tells me I'm below. So I know between this here and this here, I know I'm going to be going down. So now, and obviously if you plug in a 2, it's going to give you a positive number, which is going to take you back out. So you know, which we already knew. We already knew that from this point on we were below, and from this point on we were up, because our end behavior being an odd degree and a greater than 0 tells us that. So basically you can just, you know, this is above because that was our positive there. So we know that the graph is going to look like this. And you can actually plug it in and get the points. So like between at -1.75, the answer is 0.3. So it's like super small here. So it's actually barely over. So if you wanted to be exact, but just to get a general idea, we know it looks something like that. All right, now relationships among x-intercept 0 solutions and vectors. So C is considered a 0. Okay, so that's why whenever it's like x is 5, 5 is your C. That is your 0. C is a solution to f of x equals 0, and x minus c is a factor. All of these things are pretty interchangeable. So for example, when we're looking at this right here, I look at it and I see each factored piece. I see this is a factor, this is a factor, and this is a factor. From my factors, I set them equal to 0, and I get solutions. Those solutions are my zeros, or better known as your x-intercepts. So first thing I'm going to do is I'm going to take the x minus 1 equals 0, so x is 1. X minus 3 equals 0, so x is 3. And x plus 2 equals 0, so x is negative 2. This is 1 degree, so this has a multiplicity of 1. This has a multiplicity of 1, and this has a multiplicity of 2 because of your exponents. So let's just change this to a multiplicity of 1. I'm just going to put M1 for multiplicity. Now, since it has a multiplicity of 1, that means it's just going to cross through. So at this point on the graph, it's going to cross. At this point, it's also going to cross. This has a multiplicity of 2, so it means it's going to touch. So instead of crossing, it's just going to bounce back like this. So I know those things right off the bat. So now, let's see. The next thing we want to do is we want to set our equation not equal to 0, but we want to set all of our x's equal to 0. So I'm going to go in here and I have negative 0 minus 1 times 0 minus 3 times 0 plus 2 squared. So negative 1, negative 3, and 2 squared is 4. So I have 3 negatives here. So 3 negatives is going to keep my answer negative. And 4 times 3 is 12. 12 times 1 is 12. So when x is 0, y is negative 12. So when x is 0, y is negative 12. So this is going to be our y-intercept. So we have our x-intercepts. So we have 1, 0, 3, 0, and negative 2, 0. So those are your x-intercepts. And then this is your y-intercept. Now what does the end look like? Well, we've got x squared, x, and x. So this is degree 4. So we have a degree of 4, which is even. So since it's even, they're either both pointing up or both pointing down. We have a negative 1 in the front. So since a is less than 0, that means that the right side points down. And if the right side points down, the left side also points down, because when they're even, they point the same direction. So if you can find the right side, and then if they're even, they'll be the same. And if they're odd, they'll be opposite. But just find the right side, and then the left side will follow suit. So now what I know is if I were to set up my intervals, so my intervals, I've got negative 2 is the smallest. Then I have 1, and then I have 3. So I have this interval here, so I'm going to plug in a negative 3. From 1 to negative 2, I'm going to use 0. From 1 to 3, I'm going to use 2. And after 3, I'm going to use 4. So now if you plug this equation into your calculator, you can get the answers very quickly. You don't have to do all of this completely by hand, so that it takes so long. So now we're going to go to y equals, and we're just going to type it in. So negative parentheses, we have x minus 1 parentheses, x minus 3 parentheses, x plus 2 parentheses squared. So now I'm just going to go to my table, and I'm going to check these numbers. So negative 3 gives me, if I plug in negative 3, gives me a negative answer. If I plug in 0, it gives me a negative answer. If I plug in a 2, it gives me a positive answer. And if I plug in a 4,
it gives me a negative answer. So most of my graph is going to be below. So let's see here. So that was step 1, and it says to do step 2 on the other page. We already did step 2. This is step 2. First, let's plot our x-intercepts. So 1, 3, -2. Know that from -2 beyond is pointing in. At this -2, it bounces, so it's going to be below. At 3, 0, and then at 1, we said we were above. We saw that we are above, and because this is a multiplicity of 1, we know we cross. To get this information here, you're going to have to do each one of those. So now let's look at step 3. So let's plot all those points. So 1, 3, and -2, negative direction. So this is going to, and so we're going to go here, and we know that it points down this way, but it bounces. So that means it's going to look like this. We know that. So at this point here, this is your last point. So this one's going down also. 0. So between 1 and 3, so that means we go through, we come up, we come back down. And then we have this -12 down here. So you're going to have a graph that looks like this. So we know the ends are both pointing down because it's even and a is less than 0. We have this point here, and between the 1 and the 3, so we know we're going through here, we know we're going through here. This was the multiplicity of 2, so we know it was just a bounce. And then you have to go through your y-intercept. So your graph will look something like that. But if you don't have the calculator and you are having to do everything by hand, then numbers. So you would do f of -3, and then you would plug -3 into all of it. So -3 minus 1 minus 3 minus 3 minus 3 plus 2 squared. And you would have to get the actual number each time. So then you would have -4, -6. That's -1 squared, which is 1. We have 3 negatives, which tells me my answer is negative. It doesn't really matter what the number is, but we know it's going to be -24. So at -3, it's -24, so it's way down here. So this point, my graph is not super accurate because it's kind of too skinny, but it kind of gives you an idea of where you're going to be on the graph. So if you looked at -3 and -24, so this would actually be like way down here, and then you come back up. But you just need to know, are you going above or are you going below in that range? And then that way you can get an idea of what it looks like. But obviously, using your graphing calculator and the points will also help. Now, our intermediate value theorem is the polynomial function with only real coefficients. And if for real numbers a and b, the values of f of a and f of b are opposite in sign, there exists at least one real 0 between them. So if they give you two numbers, a and b, and you plug them into you plug your a and your b into the polynomial function as your x values, so you'll have two answers, so whatever a is and whatever b is. If one of them is positive and one of them is negative, that means that there is an x-intercept between those two numbers that you were given. The numbers you're being given are not necessarily your x-intercepts. You use those two numbers to determine if there is an x-intercept between those two numbers. Another way to find out, okay, am I crossing or not? So we are going to use synthetic division, and we're going to graph to show that x cubed minus 2x squared minus x plus 1 has a real 0, an x-intercept, between 2 and 3. So we're going to take the 2 and we're going to divide it into 1, -2, -1, and 1. So we're going to test that out. So 1 times 2 is 2. -2 plus 2 is 0. 2 times 0 is 0. -1 plus 0 is -1. And then we've got 2 times -1, which is -2, and 1 minus 2 is -1. So when f is 2, we have a negative remainder. Now do the same thing again with 3. So I'm going to slide this up and change my color. So now 3, we have 1, -2, -1, and 1. So 1 times 3, -2 minus 3, 3 times 1. -1 plus 3 is 2. 3 times 2 is 5. 1 plus 5 is, nope, that's 6. 1 plus 6 is 7. And so when your B is 3, you have a 7. Since your responses, one is positive and one is negative, that means that you have an x-intercept somewhere between 2 and 3. So if you are thinking about your number line, here's 2 and here is 3. You are going to cross through here somewhere between, maybe 1/2, maybe 175, maybe or 275, maybe 2.3. We just know that somewhere between 2 and 3, we are crossing that x-axis. Also know, sorry, let me go. Lost a page somewhere here. Here we go. I was going to say, I just totally lost a page. If f of a and f of b are not opposites, does the intermediate value theorem mean there is no 0 between? No, there could still be a 0. Okay, there still could be a 0. It's probably just going to bounce. So no, there could still be a 0. All right. Now, let f of x be a polynomial function of degree n is greater than or equal to 1 with real coefficients with a positive leading coefficient. Suppose f of x is divided synthetically by x minus c. If c is greater than 0, all numbers in the bottom row of the synthetic division are non-negative, then f of x has no 0 greater than whatever value c is. And if c is less than 0, meaning a negative, and the numbers in the bottom row of the synthetic division alternate in sign, with 0 considered positive or negative as needed, then f of x has no 0 that's less than c. So let's do an example so we can see. So we have the function 2x to the 4th minus 5x cubed plus 3x plus 1. So we have 4, 3, there's no 2, so we're going to need a placeholder. So be careful of that. Don't forget about those. So no real 0 is greater than 3. So what we want to do is we want to find out. So using the 3, if all the numbers, since my c is, since 3 is greater than 0, says if c is greater, all numbers in the bottom row of synthetic, if they're all positives, then that means there is no x-intercept greater than 3. So if it comes out that they're all positive, then that means 3 is the biggest x-intercept you have for that function. So we have 2, -5, 0, 3, and 1. So let's do it. So that's 6, 1, 3, 3, 9, 12, 36, 37 is our remainder. All of our numbers are positive. So that means no real zeros are greater than 3. So 3 is your biggest x-intercept. Let's scribble this through. All right, let's try it with this one. So now we have -1. We're going to use the same numbers. 2, -5,
0, 3, and 1. So 1 times negative 1 times 2 is negative 2, negative 7. Negative 1 times negative 7 is 7, 7. Negative 7, that's negative 4. That is positive 4. And this is 5. So we got positive to negative, negative to positive, positive to negative, negative to positive. So these alternate. So that means no real zero, less than negative 1. So basically, if you look at your graph, you've got a 3 here and you've got a negative 1 here. Since we have 4 possibilities, they're all between those two numbers. There's nothing on this side and there's nothing on this side. Everything is happening between the negative 1 and the 3. Okay, I think all right, so here is our last piece. So approximate the real zeros. So to approximate the real zeros, we're going to use your calculator, okay? That's honestly the easiest way to do it. We're gonna type it in, do some, and then if you're using Desmos, you can look at the graph, you can zoom in, you can approximate what your zeros are. What I do know is that it is a degree 4. So we have a degree 4, and 1 is greater than 0. So that means both of my ends are going to open up. And then it's just going to be like this in between. So, because it's got to cross 1, 2, 3, 4. I know that there's at most 4 zeros. When x is 0, if I plug in 0 for all of this, my answer is negative 1. So my y-intercept is at negative 1. Let's see. If I type this into my calculator, so let me go back to y equals, and I'm going to type in x raised to the 4th minus 6x raised to the 3rd plus 8x squared plus 2x minus 1, and then I hit my graph. And I see that the graph shows 4 real zeros, so I can see that it is crossing the graph. Just looking at it, I can see that it's crossing. So if I go to my table, I want to know where it's crossing. So I see that it's crossing at negative 1, or, oops. So I know that my, sorry, my y-intercept is here. And now my x-intercepts are when y is 0. So I see that it's crossing from 0 to 1. So from negative 1 to 0, it goes from positive to negative. So that tells me that it's crossing right there. And then it goes back. So then from 0 to 1, it's crossing. And then between 2 and 3, or actually, yeah, between 2 and 3, I look at my table, and when it's 2, it's a positive 3, and when it's 3, it's a negative 4. So it's crossing from y being positive to y being negative. So between those 2 points. And then between 3 and 4. So if I'm looking here, I've got negative 1, 0, 1, 2, 3, and 4. So between these two, it's crossing. Between these two, it's crossing. And then between these two, it's crossing. And between these two, it's crossing.
And I know it's pointing up, so I know this is going to go this way, and I know this is going to go this way. And then everything else, it's just going to look something like that. Now, to approximate what those are, like I said, if you're using Desmos, you can zoom in and get an approximation of what they actually are. I'm going to use the graphing calculator, the TI-84. So I am going to erase this where I have some space over here. So you're going to go second trace. And when you hit second trace, it gives you a menu, and you're going to go down to where it says 0, because I want to know what the zeros are. And now when I hit that, it takes me to my graph, and there's a blinking cursor. And at the bottom it says left bound. So what I want you to do is use the white arrows, and I want you to move that cursor using the left arrow until you're above, and you're a little to the left of the answer, and you're going to hit enter. Then you're going to hit the right arrow and go below where it crosses, and you're going to hit enter again, and then hit it one more time. And it's going to tell you that this first 0 right here is negative 0.414. So this would be there. And then you repeat that, second trace 0, and then you do left bound, right bound, enter, enter, and then you do it again here. So the left bound means the cursor, you're just going to blink somewhere here. Right bound, you're going to blink somewhere here. Then for this one, for left bound, you're going to blink up here, and right bound, you're going to blink somewhere here, and it's going to give you that one. For this point, you're going to blink somewhere here. For right bound, you're going to blink somewhere there. Every time it's going to give you the answer. I'm going to try one more, so if you're trying it, you know you're getting the right answer. So I'm going to do second trace 0 again. I'm going to move my cursor till I'm down here somewhere, because I'm looking for this point. And I'm going to hit enter, and then I'm going to move my cursor till I'm up here. I'm going to hit enter, enter, enter. And now it tells me that this point is approximately 0.268, because it's 2.79. Or 0.279. And then I just repeat that process until I have all of my points. Okay? All right. Now this last part, again, you're going to put this in, create your list. So I'm just going to quickly go through this, and you can come back if you need to. All right, so the table is showing the price of cookies from 2007 until 2018. And it says to start with 0. So this is actually 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So over 11 years. And these are going to be your X values. We're going to put these numbers into the list in our calculator. So we're going to go stat, edit. And this is going to be your L1 column, and this will be your L2 column. So I'm going to come over here, I'm going to go 0. And then type it all in. Now once you've got all of these numbers in stat, and then you're going to go, for each one of these, you're going to look and see, what does the equation say? Okay, so stat edit, you got your L1, your L2, and then you can plot it and look at it on the graph. But they want you to determine if it is quadratic. So when you go to stat, edit, and you create the list, once you have your list created, you're going to go stat, calc. So now you're going to go stat, you're going to arrow over to calc, and they want to know about quadratic. So you're going to go down to number 5 where it says quad reg. And it's going, and you're going to hit enter, and then just go through, and you can hit calculate. And let's see, mine is giving me an error message, but I did it already. When you go through and you type it all in, if you do a quadratic, it's going to tell you that the equation is y equals negative 0.0139 x squared plus 0.2095x.
plus 2.7422. And then you graph that. Then you do it again. You're going to go back to Stat Calc. And this time, you want to look for the cubic. The cubic is number 6. And you do the same thing. So I need to look at my stat edit. It's telling me my list is wrong. So then once you go through, and now it's going to give you a new equation. It's going to tell you that y equals 0.0022x cubed, because it's cubic, minus 0.0502x squared, plus 0.3626x, plus 2.633. And then you can type that into y equals. And what I did is I typed this into y1, I typed this into y2, and then I did it one more time for the quartic. So this is my y3, because I want to graph them all at the same time, and I want to see which one goes through these points. And I'm going to show you how to turn the points on. So we have 0.0006x to the fourth minus 0.011x cubed plus 0.038x squared plus 0.166x plus 2.7. So when you type all of those in, and these points are graphed on, so to get these points to plot on your graphing calculator, you're going to go second y equals, and it says stat plots, so hit 1, and then you got the option between off and on. Just turn it on, and then when you go to your table or your graph, it'll have all these points randomly plotted, so it'll be like you have all these points. Then each one of these equations will go through your points. You choose the equation that fits the best. Whichever one fits the best is the one you're going to work with. Now, you do need to make sure that your diagnostics is on. So if you do second 0, it gives you a catalog. And you're going to scroll down till it says diagnostics on. And what happens when you are doing your 3 equations, you're going to see there's values of an r and an r squared. The closer the r squared is to 1, that is the better fit. You can also look at it and see, but it's going to be very close with these. But what we did is I saw that in equation A, my r squared was 0.8276, and in B it was 0.8923, and then in equation C it was 0.9293. So that told me that the quartic function was the best fit because my r squared is closer to 1 here. And then when you graph them, like one of them went this way, one of them was kind of a curve this way, and one of them went this way. Whichever one fit the best was going to be that one there. All right, so we have one more section out of here, and then we are moving on. Have a great day.